Alright, so this video is going to be part 5 of our convergence and divergence problems with series. So again, we want to prove if this series is convergent or divergent. We have the series up here, the sum from n equals 1 to infinity of n squared minus 8 over 3 n to the 5th plus n cubed. Now, of course, this is not going to be a p-series or a geometric series, so we're going to have to go through our tests here. So first off, test for divergence. That's a great one to try. Now, since we've already done 4 videos of this, you should be able to tell right away if this is going to be divergent by the divergence test. And since this is the highest power on the bottom, okay, you'll obviously see that this is not going, the divergence test will not tell us anything. So we can put a big red X there, okay? The limit as n approaches to 0 of this will equal 0. So divergence test doesn't tell us anything. Now, the integral test, well, that nothing is really sticking out here that we can do an integral with, so just going to put an X there. What about comparison test? Okay, well, this seems actually like we could probably do it here. Let's take a look. If we tried to compare n squared minus 8 over 3 n to the 5th plus n cubed to n squared over n to the 5th, maybe we could do that. Well, you have a minus 8 here, okay? You have a minus 8 in the numerator, so the numerator is already less than this one, and you have a larger denominator, okay? And that means that this whole fraction is going to be less than n squared over n to the 5th, okay? N squared over n to the 5th, that's also known as 1 over n cubed, okay? And we know that this series right here, the sum from n equals 1 to infinity of 1 over n cubed, converges. We know that, right? It's a p-series. P is greater than 1. Okay? So since that converges, because I shouldn't have circled it because it's not our answer, but since this converges and this is greater than our series that we're dealing with, well, that means that this series will converge by the comparison test. Alright, so next problem, we want to prove if this series is convergent or divergent. We have the sum from n equals 1 to infinity of rad n over n squared minus 1. Okay, now again, test for divergence, not going to work here. Okay, we have our highest power of n on the bottom, our limit is going to equal 0. What about an integral test? Well, doesn't really look like it with that square root there. It's going to give us a hard time, so no. Comparison test, well, maybe we could do that again. Who knows? Let's try it. If we try to compare rad n over n squared minus 1 to, well, this will be a rad n over n squared. That's what we'll be comparing it to. Rad n over n squared we can also write as 1 over n to the 3 halves. Okay? It's going to be an n to the 1 half over n squared. You subtract the exponents. You get 1 over n to the 3 halves. Okay? So what is going to be the relationship here, though? Okay, because we know this converges. Okay, it's a p-series, p is greater than 1. But this, however, this denominator is smaller, which means that this is going to be bigger. Okay, and that's a problem. Okay, that's a problem right there, because since this converges, this isn't going to tell us anything by comparison test. Okay, so comparison test actually won't work here. Okay, so we got to put in an x here. Now, we can try limit comparison test, though. Limit comparison test, we take the limit as n approaches infinity of the, no, we don't use absolute value here. Okay. The limit as n approaches infinity of a sub n, which is going to be our original series, the square root of n over n squared minus 1. And that's going to be over the series that we're comparing it to, right? That 1 over n to the 3 halves. Okay, now what we can do is just get this all into one fraction. So we get the limit as n approaches infinity of, this is going to be an n to the 1 half, okay, n to the 1 half times n to the 3 halves over, this will be a n squared minus 1. Okay, and, well, n to the 1 half times n to the 3 halves, that's going to be n squared. So you're going to get the limit as n approaches infinity of n squared over n squared minus 1. And of course you can divide by n squared. You can divide every term by n squared. You can use L'Hopital. You're going to get that this limit is equal to 1. Okay, 1, that's greater than 0, and it's a finite number. Okay, it's a finite number, which means that both these series are going to either converge or they're going to both diverge. And since we know that this converges, okay, well, that means that this is going to converge as well. So this converges by the limit comparison test. Alright, so that is going to do it for this video. In the next couple videos, I'm not sure how many I'm going to make here. I'm going to try to get to 10, but we're going to be doing some work with absolute convergence and conditional convergence as well. Okay, so we'll be doing kind of like an expansion on this problem. So not only do you have to prove if it's convergent, but you have to see, is that convergence going to be conditional or absolute? Okay, so that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.